Hey there, welcome to this video 2A-1. We are going to talk arithmetic sequences. Alright, kicking off this new unit. Unit 2A, arithmetic sequences. We're going to learn about how to solve problems involving arithmetic sequence, what a sequence is. And so to be successful, one, you have to be able to identify what an arithmetic sequence is. That usually comes with being able to find the common difference, as well as being able to apply the arithmetic sequence to find any term in that sequence, as well as when you have an arithmetic sequence, understand what rate of change is. So let's go ahead and first start off with what a sequence is. A sequence is a function with a graph consisting of discrete points instead of a curve. And so if you go ahead and look at this data here, my numbers are 1, 3, 5, 7, 9. And so my first term here is 1, my second term is 3, third term is 5, fourth term is 7, so on and so forth. This is a sequence. It's a list of numbers. So successive terms of an arithmetic sequence have what we call a common difference, or they change at a constant rate. And so for this example here, you could see from 1 to 3, we are adding 2. And then the same from 3 to 5, plus 2, 5 to 7, plus 2, 7 to 9, plus 2. So that's what an arithmetic sequence is. It would have a common, what's called a common difference. D is equal to 2. And so again, here's another example. I have 1, 4, 7, 10. The common difference, you can subtract any term by the term before it. So 4 minus 1, your common difference is 3. It's pretty easy to spot, right? It's like pattern recognition. So I want to go into some notation first, is how we kind of define terms in a sequence is with this mathematical notation with subscripts. So we would say a sub 1. And really the A is indicating arithmetic. So if you are given a problem and you don't know if it's an arithmetic or what we'll talk about in the next lesson, a geometric sequence, this A will indicate, hey, you have an arithmetic sequence going on. So A equals 1, A sub 1 equals 1, A sub 2 equals 4, A sub 3 equals 7, so on and so forth. And this is really beneficial too, because if we end up having to graph these, really this subscript notation is more like an X value, right? This is your X and then this is your Y. So that ordered pair would be 1, comma 1, and then the next ordered pair would be 2, comma 4, and the next one 3, comma 7. And again, we could make this like a table too. So sometimes you see arithmetic sequences given in tables. 1, 1, 2, 4, 3, 7, so on and so forth. Now, one term in sequences that is not given is what is called the initial term, or a sub 0, or what we call a naught, an initial value. And how we find this is you usually have to go backwards in the opposite direction. So in this case, since we are adding 3, we would have to subtract 3. So our 0th term, a sub 0, would be negative 2. That's your initial value, okay? Now, because I have a sequence and there's a pattern, right? This comes with mathematics. We want to be able to predict. So we want to be able to predict. Well, we can go ahead and find any term in a sequence called a sub n. This is called a general term. The general term, or any term, a sub n, is found by starting at your initial value, a sub 0, and I am going to take this common difference, whatever we've been adding by, and multiply times whatever term it is. Okay? And we'll go ahead and put this into play. But what if I don't have the initial value, or what if the initial value is super difficult to find? We can use any term at all. We can use the kth term, a sub k, and all we do is we just subtract that k value from n. Okay, and again, I'll show you an example when we look over here. So in this case, right, our initial term was negative 2. So I start at negative 2, and if I want to find any term, I'm just going to add 3. This is my common difference, right? We were adding 3 n times, right? So if I want the 5th term, a sub 5, well, a sub 5 is going to be negative 2 plus 3 times 5. So that's negative 2 plus 15, which gives us 13. Now, it's not that hard, especially if you're close right here, right? Like, you know, I could just add that. The fourth term, I'm going to add 3. It gives me 10. And then the fifth term, add 13. But sometimes they make it difficult. They add like the 100th term. Okay, say I didn't have the initial term, or the terms that I had were super far apart, we can use the kth term. And so let me show you how the kth term is. If I wanted to use this term right here, the fourth term, 4, 10, well, I can start at 10, and all I have to do is I add that common difference. I add my plus 3, and then from the end, I'm going to subtract whatever term it was that I started with, so n minus 4. Okay, so let's go ahead. Without further ado, let's look at an example. Here's an example. Okay, values of the terms of an arithmetic sequence are graphed in the figure. Use the information in the figure about the arithmetic sequence to answer these questions. And I'm going to kind of bounce around, in a different direction than it's listed from the A, B, C, D. So they say here, what is the common difference? What's the common difference? Well, it looks like my first term here is 9, then I have 7, then I have 5, then 3, then 1. So it looks like my common difference here is D is equal to negative 2. We are subtracting 2 every single time. Okay, general question, what is the third term? C, what's A sub 3? That's how we read that. What's the third term? Well, my third term is going to be 5. My third term produces 5. So that's my third term. And we can kind of do some predicting here. What's going to be the sixth term? So my fifth term is 1, and I'm subtracting 2. So then my sixth term is going to be negative 1. A sub 6 will be A sub 5 plus whatever that common difference is. So I add 1 minus 2 gives us negative 1. And you don't have to show this math. You know, you can just, on these simple ones, you can just produce. And then here, A naught. What is A naught? Our initial term. So that would be your y-intercept. And I'm going to go ahead and kind of put this in parentheses here. This is your initial value, or your y-intercept. That's going to be on your y-axis. So I guess here I'm subtracting by 2. So to go this direction, I'm going to add 2. So I should get 11. A sub naught would be equal to A sub 1 minus D. So in this case, we have, is that 7? No, 9. 9 minus negative 2, we get 11. Okay, there's your initial value. So, what would our expressions be? What would our expressions be? They have here, write an expression for the nth term using this form. This is kind of like your initial value. So A sub n, to find any term, I can start with my initial value, which was 11. And what I'm going to do is I'm going to add the common difference, which in this case is negative 2 times n. And I want you to see, you know, how this is similar to what I'm going to do in the next one. So if I want the nth term, say it's the 100th term, I can just plug in 100 and get that value. So, but what if I didn't have my initial value? What if I had to use some other term, some other starting point? And I can use any of these terms, doesn't matter. I can use any of them. It's exactly the same formula. So A sub n equals, okay, where do you want to start? They tell us here. Start at the 12th term. So what this is saying is A sub 12 equals negative 13. So I'm going to start at negative 13, and I'm going to apply my common difference, which is negative 2. Right? Here I put a plus, but so minus 2 times, how many times? Well, how many ever times I need to minus where I started, which is the 12th term. So minus 12. And I'll put it in black so you can see. Okay, I plugged in this 12. I'm taking away 12. Okay, so say I wanted the, I don't know, 16th term, I would only have to subtract 2 4 times, right? So I plug in 16, I get 4. Okay? And we'll see some applications. But here is a sequence. Go ahead, pause me, and then fill these in, and let's see if we get the same answers for this example. Okay, the first term here in a list of sequence they give us 3, then 8, then 13, then 18, then 23. This is a common difference. This is an arithmetic sequence with a common difference d of 5. The fourth term, just by reading it, is 18. And then going backwards to find my initial value, I subtracted 5. So 3 minus 5 gives me negative 2 as an initial value. And my seventh term, I went forward, I added 5 twice, so to give me 33. So those hopefully were pretty easy. And then we get to the equations, which are probably the most useful and applicable of this lesson. Using my initial value, and here's where I'm going to introduce the y equals b plus mx, or mx plus b, a straight line is what I want you to start to see, is that I'm starting at negative 2, and I'm going to add my constant rate of change, which is 5 every single time, times n. Okay, so there you go. There's your function. Now we can rewrite this using not my initial value, but what if I wanted to start with my 8th term? Well, the 8th term is 38, so I start at 38, and I'm going to add 5, how many ever times, but I take away 8, because I've already done it 8 times. Okay, so very similar, and I want you to look up here, right? Isn't this the same thing as if I did this? Isn't my 0th term negative 2? Okay, we just don't write that. Okay, so hopefully you got that correct. Okay, practice problem. Consecutive terms of an arithmetic sequence have values 4, 1, negative 2, negative 5, negative 3. What is the constant rate of change of the sequence? Well, that common difference or that constant rate of change is negative 3. We're subtracting 3, and that's a constant rate of change. All right, so what are some applications of finding terms with arithmetic sequence? So let's go ahead and see. They say here in this question, for an arithmetic sequence, the third term is 15 and the fourth term is 11. What is the value of the 20th term? So when we go ahead and do this, I can go ahead and I can set up an equation. A sub n equals a sub k plus d times n minus k. And I can plug in this given information in order to help me find the common difference. Now, I know it's really easy. You can probably tell me, why are you doing all that? I know the common difference. I want to do this because on your homework, or maybe this question's already been replaced with something more difficult. I'm going to make it generic here. So if you have two pieces of information, in order to find the 20th term, I need to know what my common difference is. So I can find this. Because I know my fourth term. I know that a sub 4 is equal to my third term, a sub 3, plus the common difference times 4 minus 3. Okay, and so again, I could plug this in with any terms that are given. So my fourth term in this case was 11. 11 is equal to 15 plus 4 minus 3 is 1 plus d. And then I could go ahead and I can solve for d. And in this case, we know, this is not a secret, we know that d is equal to negative 4. So what's my 20th term? Well, a sub 20 is going to be equal to a sub k. I can pick any term I want, plus my common difference, which is negative 4, times 20 minus k. And usually what I do is I start at the closest point. So like if my fourth term's 11, I'm going to start at 11. 11 minus 4. How many times? Well, 20 minus my 11 is the fourth term, so I'm going to take away 4. So I get 11 minus 4 times 16. And so we get 11 minus 64, which gives us negative 53. Okay? So, if they ever ask you what's the 20th term, if you don't have your common difference, or for geometric sequences, your common ratio, you got to find that first using this equation. Okay? All right, let's look at some practice questions. Here's for you guys. For an arithmetic sequence, the seventh term is given by a sub 7 equals 9. The common difference is negative 8. What is the 25th term of this sequence? Go ahead, pause me, try this example. Okay, the 25th term is negative 135. Hopefully you set up this equation. A sub 25 is equal to a sub k plus d times n minus k. Well, in this case, a sub 7 is given. I know that the 7th term is 9, so I can replace that 9 minus 8 times, and I want the 25th term, and I'm going to take away 7 because I started with the 7th term, which was 9. So there you go. 9 minus 144 gives us negative 135. Did you get it? Okay. Similar question here. Go ahead, try this example. Okay, they tell us the first term is 6, common difference is 3. What is the 8th term? Well, if I start with 6, I can go ahead and add 3 7 times, right? 8 minus the 1, and we get 27. Okay, last practice problem here. They say the general term of a sequence is given by a sub n equals negative 10 plus 2 times n minus 5. Which of the following expression also gives the general term of the sequence? Go ahead, pause this one, try this example. Okay, hopefully you got C, negative 20 plus 2n, and all you had to do was distribute. If you distribute your constant rate of change, that common difference, to both terms here, you end up getting negative 10 plus 2n minus 10, and we can combine those negative 10s to give negative 20, 2n minus 20, which is negative 20 plus 2n. So really, both of these forms that we've been working with, the initial value form, which is what this one is, right? If I start with negative 20 plus 2 times n, it's the same one as if I start with a different term if I distribute everything out to get them, okay? So hopefully in this video you learned about arithmetic sequences and how to identify the common difference, and you were able to generate an equation to find any term of an arithmetic sequence. The rate of change for an arithmetic sequence, what I hope you picked up on, is a common difference, something that you're adding or subtracting by at a common rate, making this a linear function. All right, go ahead, give this video a thumbs up. In the next video, we will talk about geometric sequences, what happens when numbers change proportionally. Catch you later.